Lesson 25, page 116. Monomial factoring, cancellation, and parallel lines. And I apologize, I haven't even looked at this lesson. Oh well. We'll see if I can wing it. All right. Monomial factoring. What we're looking at here is taking something and factoring it into not necessarily always simpler units, but usually when we factor it's because we want to put it in more manageable units. So what we're doing is we're taking several factors and finding if there's any commonality between them. Bless you. So you look at both of your terms, and you look first of all at the numbers, and then you look at the letters. And you see if there's anything common between them. Now this one here is obviously, you look at the numbers and 4 is common. But that's not always going to be the case where the numbers are common, but you can still factor. We'll look at that in a minute. So, you have a 4 that's common. What else do we have that's common?
X.
We have an x. We don't have an x squared common because we don't have an x squared in our second term. It only appears in the second term has an x, so that's the biggest we can pull out is an x. So that's what's common to both of these. We don't have an a and we don't have a second x, so we can't pull those out. And then what we're going to do is we're going to write what's left.
I remember these.
When we write what's left, what we're doing is we're dividing by what we started with. So we're dividing 4x into 4ax squared. So basically what we're doing is 4x times something is going to give us our 4ax squared back. What are those somethings? An ax. And what can we, plus 1. A lot of you will write 4x times ax and be done because you're going to say, oh, but this disappeared. No. There's always a 1. All right, let's do one that is not any more difficult, but a little different looking. 4x squared p squared k minus 6k squared p to the 4th x. Okay, what is common to both of those terms numerically?
2.
A 2. It's the biggest number that will go into both the 4 and the 6. 4 goes into 4, but it doesn't go into 6 evenly, thanks Zach. So a 2 does, which means, whoops, we'll just leave that 2 there. All right, now let's look for x's. I've got 1x. One of the key things when looking for what you can pull out is it's always the letter that has the lowest exponent of any of the ones in there. So this, we've got an x here and an x here, but the lowest exponent is here. Now we look at the p's. We have a p squared and a p to the 4th. We look at the lowest exponent. That's the one that comes out. Do the same thing with the k. We have a 1 and we have 2, so only 1 comes out. Now the part that students get confused with is what's left over. Leave my k's alone, Riley.
I know.
Looks more like an R.
I thought that was like an L.
Stop it!
An L? How did you get L out of it?
I thought he just messed up on accident when he pulled the little thing.
Is that from your mechanic class?
Maybe it was a cap.
There.
Thank you.
Much better.
What is that like?
Oh,
spider leg right there?
I like that. That looks
Okay,
It's like an unfinished
what
ring
do
with
I
a line.
have left?
2x.
He didn't put the top. Mine.
I have 2x. Is that all I have?
Yep.
No.
Well, then you have a subtraction sign.
What do I have here?
3k.
You have the H on the end of the
squared.
P squared.
And that's it.
And that's it.
Call this.
It's anti-distributive property.
Yeah. That's kind of what we call it. I call it anti-foil, anti-distributive, anytime you go backwards. Yes.
The title says mononomial factoring, so might be binomials.
Yes, they are.
Oh, snap.
Not really sure
Adam just-
what in the world they're talking about. I think John was having a bad day when he wrote this.
I think he was having a bad day when he wrote the book.
Oh,
Hey.
It's all bland and just.
John is great.
Who's John?
The guy that wrote the book, John Saxon.
Oh, got it.
4x squared y. Did anybody ever find out when his birthday is?
Can that be
Remember,
October
it's-
13th?
Very important for a party.
Wait, can we,
Okay,
can that be an extra credit question?
so how do we factor this?
No.
What number is common to 4, 2, and 10?
2.
2.
X.
Whoops.
Plain old X. Plain old Y.
Okay, so I can take a 2 out. What else is common? X. And
No Y. Oh, there's a Y at the end of that.
leaving me with
2x minus 1 plus 5y. Parentheses.
Notice, Seth made sure
End of parentheses.
he had his 1 there even though he pulled everything out. It doesn't turn into a 0.
Attaboy, Seth. Remarkable.
Okay, cancellation, which is the next section in here. The only time,
Oh, it is coming up.
Erica,
She had the book.
the only time, did you find it, Kara?
I found a 76-year-old actor named John Saxon.
No, that's not him. He was an engineer.
There is John
Probably
Saxon.
dead by now.
Oh, he is.
It is recorded.
It's his son.
He did die. I'll have to look in some of my material. I'm sure there's some place somewhere.
John Saxon Jr.
Oh, yeah, that's what it says. Educator?
There you go.
Birthday's today, we should not have homework because of it instead of homework.
Find anything?
It's Kara's
Okay, while
birthday,
she's
buddy.
looking, cancellation
He's from Norman.
can only occur
I'm talking about.
with multiplication happening between terms, not addition or subtraction. I always tell students that the addition and subtraction sign are kind of like chains holding the numbers together. They can never be separated. The only time you can split those numbers up is if there's multiplication. So, for example, if I have 6x cubed plus x squared over x squared, I cannot cancel this and this, because you cannot cancel if there is a plus or a minus sign on either side of what you want to cancel, because that plus and minus sign locks all of those numbers together. This is not x squared. This is 6x cubed plus x squared. Okay? Which means the last bit of information you learned was factoring. We're going to factor always before we cancel. Yes, Zach?
October 17th.
October 17th? That's like coming up.
Write it on the board,
like-
yeah.
Well, you guys owe Kara, thank you.
Thank
Thank you,
you.
darling. Thank you, Kara.
You put
What day is that this year?
That's
A Wednesday?
That's a Wednesday.
Okay, so next Wednesday, our last day of school before.
Hot dog, no
How
way.
convenient.
We don't have school Thursday and Friday of next week.
I thought this year was a half day.
Full
No.
day.
That,
We have 2 more weeks left.
Is college fair?
No, that's Sunday.
I thought we
I
had.
meant same week though.
Yeah.
I thought we had
Okay, guys, anyway, back to math.
next week and then a week after that. And then
Need you to listen.
What are we going to bring?
Before you cancel, always factor if you can prior to. So we're going to factor this. What do we have on the top if we were to factor? What can I pull out? What's common?
X squared.
Okay, why did you pick x squared?
Because everything has 2 X's.
Because it's the smallest exponent on the x. And that leaves me with 6x plus over x squared. Now is there a plus or a minus sign on either side of the x squared in the numerator?
No.
No, that's the case. Now we can cancel. And you end up with 6x plus 1.
Yeah! The people on our recording probably are excited to figure out October 7th.
October 17th is a party.
Okay. So, 8x to the 5th plus 12x cubed over 4x cubed. Factor and cancel, please. Okay, hands up, you got an answer for me. Riley?
X squared plus 3.
How many squared?
2x squared.
2x squared plus 3. Anybody else get that?
Yep.
Yeah.
Okay.
No, you're right. Are we right?
Yes. So, always factor, then do your canceling. Parallel lines. We have done we have done similar triangles, some that look like this, some that look like this, only if these two are parallel, which I think they have to be, for those to be similar triangles. Parallel lines also tell us that triangles are equal. So if I have a triangle, come on. And then I have a line like that. When I do that, I'm saying that my triangles are similar. Because these are going to be similar, and these are going to be similar. And angle, angle means...
Angle, angle means angle, angle, angle.
There you go.
What?
Angle, angle, angle.
Actually, you don't even have to write two of them, do you? Because they automatically share the third angle. Because it's the same with the triangle. So you only need one angle, right?
So angle means angle.
In this case, right?
Yeah, yeah. And sometimes, guys, when you're doing this work with your homework, you're going to have to extend these lines because they may give you some information that you're going to need the other angles as well. So, don't neglect to take into account that some of those lines are going to extend, because what we've got here is we've got a parallel line there and a parallel line there, which means we have two transversals. So we can tell that this angle and this angle are the same, this angle and this angle. I mean, we can make a lot of assumptions based on the transversals. So keep that in mind when you're doing some of this work. So your homework is right here. Your practice problems.
Better. She's not a dog, you know.
1 to 20 all, 21 to 29 odd.
Ooh, I did not expect that.
Alright.
Don't
I'm so
Say
surprised.
anything like that, Dad.
Because it's always.
Hey, I can make a change. That's 1 through 30 all.
Hey, I'm just joking. It was just a joke.
Thank